Solve the triangle. We've been given 3 sides and no angles. We need to find the 3 angles. We're going to use the law of cosines. Let's first find angle A. We will use this form of the law of cosines that involves the angle A. Substituting in our values, we get 5 squared is equal to 8 squared plus 4 squared minus 2 times 8 times 4 cosine A. The biggest problem in using the law of cosines is that visually we might want to group these numbers together, and that is wrong. We need to remember that these numbers here are married together with multiplication. Let's do some simplifying. 25 is equal to 64 plus 16 minus 2 times 8 times 4 minus 64 cosine A. In isolating cosine A, we first want to subtract the 64 and the 16 from both sides of the equation. This will give us negative 55 is equal to negative 64 cosine A. Now to isolate cosine A, we can divide both sides of the equation by negative 64. Cosine A is equal to 55 over 64. We can now use our inverse cosine function to find A. Before we use our calculator, we have to know whether the directions want us to find the angle in degrees or radians. In this problem, we are asked to find the angles in degrees and to round to the nearest tenth. A is equal to 30.8 degrees. Because we have an angle, angle A, and the side opposite the angle, little a equals 5, we might be tempted to use the law of sines to obtain angle B. But we need to be careful. Angle B is side B is the longest side. And if angle B is obtuse, the law of sines will not give us the correct answer. Therefore, let's use the law of cosines again to obtain angle B. We will use the form of the law of cosines, which involves angle B. We will substitute in our values for B, A, and C. 8 squared is equal to 5 squared plus 4 squared minus 2 times 5 times 4 times the cosine of B. We'll do a little simplifying here. And again, don't be tempted to do this calculation. That would be wrong. We first need to subtract 25 and 16 from both sides of the equation. That leaves us with 23 is equal to negative 40 cosine B. Now to isolate the cosine b, we will divide both sides by negative 40. This gives us cosine b is equal to negative 23 over 40. We can now use our inverse function to obtain angle b. b is the inverse cosine of negative 23, 40. Because the number we're inputting into the inverse cosine function is negative, we will obtain an obtuse angle. Again, we need to find the angles in degrees and round to tenths, so our calculator should be in degree mode. Angle B is equal to 125.1 degrees. If we use the law of sines, we would get a positive acute angle, and this answer would be wrong. For our third angle C, we can simply subtract from 180. We'll take 180 degrees, the sum of the angles of a triangle. Subtract angle B, 125.1. Subtract angle A, which was 30.8 degrees, and we will get, for C, 24.1 degrees. We have solved the triangle.